Hey, seventh graders, it's Mr. Sarley. Welcome back to your YouTube review. Check out the front for a little bit. I'm going to go quick on it because once you see it, you should be able to figure them out, and I'll spend most of the time talking about the back. Alright, so this first problem says 1/5 plus 1/5. When we have fractions and we're adding them, the denominator is telling us how big the pieces are. So I know my answer is going to stay fifths because if we have a whole broken up into 5 parts, 1, 2, 3, 4, 5, 1/5 would look like this. And if we added another fifth, it would just be like that. So the numerator in purple is basically counting how many parts we have, and the denominator is telling us how big the parts are. So it doesn't become 2/10, it becomes 2/5 because we have 2 of them and each size is 1/5. This is the exact same thing as 2 times 1/5, because 2 times, well, think about it with a regular number. 2 times 3 is really just 3 plus 3. So 2 times 1/5 is really just 1/5 plus 1/5. It's basically like saying we have 2 groups of 1/5. So since that's the same, I know that my answer is going to be 2/5. And if you wanted to do it the old-fashioned way that you probably learned in 4th grade, you could have rewritten 2 as 2 over 1, multiplied by 1/5, multiplied across, and gotten the same answer, but honestly that takes forever, so you should probably just think about it. 1/3 plus 1/3, so that would be 2 pieces, each of them is a third big. 2 times 1/3 is the same. 1/4 plus 1/4 plus 1/4, well, that would be 3 pieces, and each piece would be a fourth big, so it would be 3/4. And 3 times 1/4 is the same. So hopefully, with that in the answer key, you could figure out all of them on the front. Alright, on to the back where I'll spend more time. We're reviewing ratio problems because we really need to know them for later in the year and for the state test. For those of you who had me last year, you remember this problem. This is my niece. She was a 5th grader then. She's a 6th grader now. Her name is Riley, and she lives in Wisconsin. It says, Riley, Mr. Sarley's niece, runs for Janesville's cross-country team in Wisconsin. During warm-ups, she runs 10 meters in 2 seconds. Alright. So in these ratio problems, we're looking for a rate, which is telling us basically, I guess, something that's repeating. So for every 2 seconds, my niece runs 10 meters. If she continues running at that rate of 10 meters every 2 seconds, how long will it take her to run the 100-meter dash? Alright, so a longer way to do it would probably be with the double number line. But it's the easiest one to understand, so let's start there. We always start off by labeling our units, so we have meters and seconds, and then our starting ratio is 10 meters every 2 seconds. So I put the 10 with the meters and the 2 with the seconds. And then I'm going to scale up and just sort of think about it. So in 4 seconds, I know that Riley would go another 10 meters. In another 2 seconds, we'd be at 6 seconds, and another 10 meters would be 30, and then so on. And if I keep scaling up like that, I see that the 100-meter dash, well, to run 100 meters would take her, at this rate, 20 seconds. Now, for those of you who really understand ratios, you know that instead of just adding, like scaling up by adding over and over again, repeated addition is the same as multiplication, which, interestingly, is exactly what we're doing over here. So if we start with the ratio 10 meters in 2 seconds, and we know we want to make it up to 100 meters because that's how long the race is, then we just think, what can I multiply by? And I could multiply by 10, and that would also give us 20. Which would be our final answer. Alright, so what's her unit rate? Remember, a unit rate is anything per 1. So we're looking for a ratio that's compared to 1. In this problem, since we know that 10 meters is 2 seconds, I would say that our unit rate would be however far she goes in 1 second. And there are a lot of ways to get that answer, but one would be just to take that 10 to 2 and break it in half, and you would get 5 to 1. So 5 to 1 is her unit rate, which is 5 meters per second. You could have also shown it like this, 10 to 2, and then just shown dividing that ratio in half to get 5 to 1. And finally, you could have set up a ratio table like this and just shown dividing that ratio by 2, and you'd get 5 to 1. And that just kind of makes sense, because if we have the ratio 5 to 1, 5 meters in 1 second, and then we just add another second, that would add another 5 meters, which we know is true. We know it takes Riley 2 seconds to go 10 meters. At this rate, how far does she run in a minute? All right, so since all the units in this problem have been in meters and in seconds, they haven't been in minutes. So something we need to remember is that 1 minute is the same as 60 seconds. And once we know that, there are a lot of ways we could do the problem. And honestly, they all make the most sense in a ratio table. So let's say we started with the ratio the problem gave us, 10 meters in 2 seconds. So 10 meters in 2 seconds. I know we want to figure out an equivalent ratio that compares to 60 seconds. And then I just need to think, how can I multiply this first ratio to get this second number? And I see that I can multiply it by 30. And 10 times 30 would be 300 meters. So that would probably be my answer. We could have also done it with the unit rate from earlier. So from earlier, we figured out the unit rate is 5 meters in 1 second. If I multiply that, well, if I multiply 1 second by 60, that would give me what we want, 60 seconds. And then 5 times 60 is also 300. And I guess one other way worth mentioning is that you could have written an equation. This is a proportional relationship. And if we're looking for a scale factor that compares one number to the other, well, it looks like I could multiply the seconds times, think about it, 2 times what gives me 10, 4 times what gives me 20, 6 times what gives me 30, times 5, times 5, times 5, times 5. Even in these problems here, 2 times 5, 60 times 5, 1 times 5. So each time what we're doing is we're multiplying the seconds times 5 to get the minutes. This equation is probably more often written like this. Notice it's an equation for a proportional relationship. And now we could substitute in what we want. And what we want is a minute. So we can substitute in 60 seconds. You gotta love how everything connects. At least I do. That's why I do this for a living. But think about what we've been learning in class with substitution and how ratios are so connected to algebra. So the meters would equal 300. We just showed it another way. Alright, so hopefully that made a lot of sense to you. Jumping back 40 years, is that when this movie came out? So this is a picture from the original Star Wars. And this guy is also in the newest movie. His name is Harrison Ford. But in the movies, he plays a character called Han Solo. So let's just make that our secret word. Guys, thanks for checking your work, staying on top of it. I will see you tomorrow.